Hello guys, and welcome back to the second video in our C++ programming for absolute beginners course. Now today in this video we'll be covering data types and variables. So as always we're going to be using Repl.it as I explained in the first video, and we're going to create a REPL. As always, select C++ and we're going to name it variables and data types, since that's what we're going to be covering today. Now, before we start, we're just going to quickly add using namespace std, as always, just to make things a little bit easier. Alright, so after you added that, we'll get right in to the content. So, what essentially are variables and data types? Well, first we're going to cover data types, and then later in this video, we'll be covering variables. So, data is essentially information. That's data in simple terms. So the definition for data, or a synonym for it, is information. And in our C++ programming language, we have five different ways of storing data. We have more, but I'll be covering 5 of the most important, or like the ones you need to know. So 5 data types, 5 most important data types that we use in the C++ programming language. Basically what a data type is, it's the different types of data we can store. And there are 5 different types that I will be covering in this video, and alongside with what variables are in C++. Now, the 5 different types of data types, or different ways we can store information in our programming language, in our C++ programs, are, first of all, ints. Now, ints are basically short form for integers, but we denote them as int. So instead of writing integers, in programming language, we just write the keyword int. Now, valid ints are numbers. So examples of numbers: 9, 0, 1, 3, or let's just say -3. Now, these are all valid integers. They can either be positive or -3. But the only thing that they cannot have as numbers is decimal points. So even if -3.0 is a whole number in mathematics, in the programming language C++, or most programming languages, if it just sees the decimal, it is considered as a non-valid integer. So make sure that it's a number without any decimals whatsoever, not even a single decimal. So no decimals at all. They can either be positive or negative. So numbers without decimals. That's literally what an integer is. Now, next off, we have strings. Now, a string is just fully called a string. There's no notation for it. We don't need to write it. You don't need to write it as str or whatever. You can just write string. Now, for strings, all we need to do is make a pair of quotation marks. So anything inside of a pair of double quotation marks is considered a string. So strings are useful as data types. Strings are useful to store text, and you can see how strings can store literally a lot of text, because it's literally anything in between of these quotation marks. So it doesn't matter how long a string is, as long as it's in between 2 quotation marks. So it's literally used for storing text. So you can say hello, hi, or you can say bye. These are all valid strings because they're inside of quotation marks. Now, if I were to do a string with nothing inside, this would be called an empty strings, and empty strings are valid strings. So anything in between double quotation marks, make sure it's not a pair of single quotation marks, must be double quotation marks when we're talking about strings. Okay, so that's an integer, that's an int, we'll just call it int for now, and then it's a string, and then after that we have what we call a char. Now, a char, the char is denoted for a character, so we would spell it out as character, just like integer. Int would be integer, but we just call it char. So just remind yourselves that char stands for character. That's what char stands for. And pretty much what a char is it is a pair of single quotation marks, so they must be single, not double. So they can't be like a string. They must be single quotation marks, and they only store a single letter. So it can't be hi. That's an invalid char. Even if it's in single quotation marks, it can only be a single character. So D, F, A, and all of that. Okay, those are examples of chars. It can only store a single letter. If I put a second one, it would immediately take away the color, showing that it's an invalid char or character. Next off, we have things called doubles. Now, a double is essentially the opposite, not the opposite of an int, but it's the same thing as an int except with decimal points, and they need decimal points. So 9.0, even though this is a double is any decimal number, but when we say decimal numbers, even though 9.0 it is considered as a whole, and it wouldn't be considered as a non-whole in mathematics, it would be considered as a whole because you could you could just remove the dot 0 from the 9 and just call it 9 because it's the same the mathematical or numerical value in C++. As I said earlier, if it sees a decimal point, it will, not like that. So it must have that. So I can write, even if 9 and 9.0 are the same thing, 9 is considered as an int, and 9 and 9.0 in the programming language C++ and most programming languages, to the computer, 9 and 9.0 are considered different values. Okay, so 9 is considered as an int value, and doubles are considered and 9.0 is considered as a double value. So examples of doubles, right? These are whole numbers, but they have decimals, and yeah, it can even be negative decimal numbers. Okay. Hopefully that explains what a double is. Same thing applied, doesn't matter whether it's positive or negative. It's just it needs a decimal point. Alright? Alright. So, hope you guys understood that. Next off, we have a bool. Now, a bool is essentially a true or false value. Now, bools can either be represented as true or false. They don't store any other value. You can see these are highlighted in blue, showing that they're Boolean values. Now, this bool is short form for Boolean, which we would type out like this, just like integer and character. Even though it's int char, it's integer and character. Even though it's bool, it's Boolean if I were to spell it in English. Now, it would be true or false. They can't store anything else. You either write true or false as the value for this. You can see where Booleans come very, very handy. Like in most applications, when you want to turn on or off dark mode, well, there's a Boolean going on in that, switching between true and false, and these true and false values is what we can use to toggle settings and change different things. So a Boolean value can only be two values, true and false. Alright, so these are all the different types of data. As you can see, strings are useful for storing text. Ints are used for storing whole numbers without any decimal whatsoever, even if it's considered a whole number in mathematics. If it has a decimal, it is a double over here. As I said, 9.0 is the same as 9 when the programming language C++ and the ways computer understand it. 9.0 is a double, while 9 is int. So 9 and 9.0 are different values for the computer. This would be a double value, and this would be an int value. 1.0, even though that's 1, even though it's the same as 1, to the computer it's not an int. Double cannot be. This 1.0 cannot be considered 1 because 1 is an int and 1.0 is a double in the programming language C++ and most programming languages. Well, specifically for the computer's way of understanding it. And yeah, empty strings are possible, just strings without anything inside. Now, next thing we're going to get into is variables. Now, as you can see, it makes sense why we should learn data types first, then variables, because the template of a variable goes like this. You would write the type, you would write the name of the variable, write the equal sign, and then you would write the value. Okay, that's how things would work. Okay, so that's like a little template of a variable. Now, in this case, if I want to make a string variable, well, I would type in the type string, and then I would give it a name. Say, my name. So I know the name of this variable, and basically what variables are is they allow us to store data in our program. So a variable can store information. It can store one of these data types. And that's why the type is always important for the variable, to show what it's storing. So whatever it's equal to must be a string. Okay, and if I type something wrong, I type something that's not a string, even though I implicitly defined the type as string, well, then we would get an error, because if it's a string type, it must be a string. So my name, you can just write Raphael. You can see they store the information Raphael. So if I want to get my name Raphael, I don't need to print out. As you can see, when we print out stuff to the console, the function is, or like what we would type in is cout space less than, and then whatever you want to print out. So the print out, so whatever you want to print out, and then the semicolon. In this case, we want to print out the variable my name. Now, is this valid code? Well, yes, it is, because let's just move all this. Well, it is because, well, this is an already defined variable. It's a string variable. Its name is my name, and its value is Raphael. If we print this out, it wouldn't print out my name, because that wouldn't be valid. My name is not a data type. The computer doesn't know how to interpret my name. But because this is a variable and it's equal to, the computer knows how to interpret a string. So when it sees this name, but then it sees its value, it will say, well, my name, I can interpret it because my name is actually, what is it equal to? It's equal to the string that stores Raphael inside of it. So I can just say print, I can just make the program print out my name. As you can see, it will say Raphael. Do the same for ints. We can create an int. We can say int my age. And then we can say this is equal to, well, 14. And then we can print out my age. And what will happen? It will print out my age. And if we want new lines, so if we want to print this stuff out separate, so if I print this out right now, look carefully at what happens. Well, it will say Raphael 14 right beside each other. So when we print this out, we need to have an extra space of lesson signs. And we say end L. Remember, you need to end L. So that's what gives a space. As you can see, so just always, if you want to print multiple things to the console, always add this end out so that C++ knows that this is a new line. So basically what this will do is this will print my name in a separate line. So 14 will just go in this nice row-like order, column-like order. As you can see, it says Raphael 14, and we can store things, right? Because what is my age? What is age represented as in real life? Well, it's represented as a number, and that's how we can use these different data types to store information that is stored in real life, and we can really contrast our life into software, and that's how software development works, is we take stuff from real life, and then we integrate that in a technology, and we show how that works. Like, we've integrated text, you know, like, this stuff is from English, and like, that's how it works. Like, programming languages can integrate things like my age through an int value. It stores a number value that is, and these are all valid variables, so it stores, this follows the rules of a string, this follows the rules of an age. But say if I put 1.4, well, it's going to highlight that, and then it will give me a big fat error that says warning, implicit, right? This is implicitly defined as int, but then why is my variable not following int rules? So this is how we can write variables, so you guys can just create a few and then print them out to the console. You can say int my GPA, just say 4.0, right? Even though this is a whole number as 4, right? In mathematics, we would consider 4.0 equivalent to 4, but the computer will see this as a different value, so we can print it out. We can just say my GPA. And this is how variables can store information. I don't need to say, oh, I need to remember this value. Oh, I need to print this. Instead of printing out this string, I can just have these nice little names that store information for me. So you can see how variables are very useful, and we can just store something in a variable and then print that out to the screen. And I hope this was a very helpful part of the course for you guys. We have covered variables and data types in a very in-depth explanation, and I hope you guys loved it and it was helpful. And stay tuned for the next video. Please like, subscribe, comment, and share this to other programmers or people who are new to programming who want to learn the C++ programming language. Now, that is it for this video, and I hope to see you guys in the next video.